Hi guys, welcome back to YouTube channel Chemistry Live UGPG. Today we are going to talk about carbonyl compounds lecture 5. So this will be highly beneficial for BSc chemistry students under CBCS syllabus. I have a simple message for you guys. Please think for innovation, be creative, learn everywhere, anytime and help to learn others. So today we are going to talk about oxidation reduction reactions like a Clemmensen reaction, Kishner reaction with lithium aluminum hydride, sodium borohydride, MPB, Meerwin Ponder Burley reduction reaction, addition reaction of unsaturated carbonyl compound, that is Michael addition. So this is on coming under CC6 paper, semester 3 and unit 3 carbonyl compounds. So this is the prerequisite knowledge everyone must have, how the reactant is converted to the product in the presence of reagent, that is known as mechanism. So mechanism shows the movement of double-headed arrow, how bonds are broken and new bonds are formed, leading to formation of product, which may be multi-step process or one-step process. So usually this is the way how we write the bond. When this bond is broken heterolytically, on which atom that bond is broken, that gets negative charge with both the electrons, that is called nucleophile. And this A plus is called electrophile because it is electronically deficient. And usually the nucleophile will attack to the electrophile, giving rise to nucleophile-electrophile bond. So let's start with oxidation and reduction. So what is oxidation? That we all know. So addition of oxygen to reactant, that is called oxidation. And in other way also we can define removal of hydrogen from reactant. Or the product has more electronegative element than carbon. Then all these processes are known to be oxidation reaction. Similarly, another way of explaining it is loss of electron. So suppose iron atom, it loses 2 electrons, giving rise to Fe2+. So this is also oxidation reaction. So let's take another example, RCH2OH. So here it becomes RCOH. So that means here addition of oxygen takes place. And again from these two RCOH, again another oxygen is added to here. Similarly, reduction we can explain in terms of addition of hydrogen to reactant. So if we take example RCOH, so that becomes RCH2OH. So here another hydrogen is added. Similarly, removal of oxygen from reactant. So here RCH2OH. So the product is RCH3. So oxygen is removed from the reactant, then the product becomes RCH3. So this is also reduction. So another way of explaining it is gain of electron. So suppose Fe2+, will accept or gain 2 electron, giving rise to Fe. So this is also called reduction process. So let's start Clemmensen reduction. So what is that? The reduction of aldehyde or ketone in presence of a zinc amalgam, zinc Hg mercury, and concentrated HCl to give rise to alkane, which is known as Clemmensen reduction. So this is aldehyde or ketone in presence of a zinc amalgam and concentrated HCl. So this CO group will be converted to CH2. So what is the mechanism? So aldehyde or ketone, oxygen has lone pair of electron. So oxygen lone pair can act as nucleophile, it will attack to the H plus ion. So you get this OH plus protonated OH compound, and this bond C double bond O will break on O plus. So you generate a carbocation here. And zinc metal can give 2 number of electron to this compound. So you generate a carbanion here. So this carbanion takes the proton. So giving rise to RCHOH R. Again this oxygen lone pair here will take the proton, attack to the proton, giving rise to OH2 plus, and the loss of water molecule giving rise to a carbocation. So again the metal zinc can give 2 electrons to this carbocation, giving rise to a carbanion, and this carbanion again takes the proton from the reaction medium, giving rise to the alkane. So this is the way how the aldehyde or ketone is converted to alkane. Next is Wolff-Kishner reduction. Reduction of ketone in presence of hydrogen and strong base, hydroxide anion or potassium tertiary butoxide in diethylene glycol. Diethylene glycol to give rise to alkane is known as Wolff-Kishner reduction. So you take ketone and you have to react with hydrogen and potassium hydroxide. You will get RCO. This CO group will be converted to CH2 alkane. So this keto compound react with hydrogen. So you will end up with this adduct and OH minus ion in the reaction medium. It will take this proton and this bond will break on nitrogen. So when this N minus will come here, this CN bond will break on carbon. So as a result, you end up with a carbanion. And this carbanion take proton from water and it would generate OH minus ion. So again OH minus ion will take this proton and this bond will come here and this CN bond will break on carbon. So as a result it will lose one molecule of nitrogen and you generate a carbanion like this. And this carbanion will take the proton from water and it would regenerate the OH minus ion. So you will end up with alkane and here the OH minus ion just act as a catalyst. Because the catalyst we use it and we get it back at the end of the reaction. The next reagent is lithium aluminum hydride. So this is the structure Li plus AlH4 minus. So how to prepare this reagent? So you start with lithium hydride plus aluminum chloride giving rise to Li plus AlH4 minus. So usually the anions are nucleophilic reagents and normally attack polarized multiple bonds like C double bond O, cyanide by transfer of hydride ion to the more positive atom. So if you give this if you react a carbonyl compound with lithium aluminum hydride, you will end up with alcohol. So this is the reactant carbonyl compound and if you give the reagent lithium aluminum hydride, you will end up with alcohol. So here this Al, so here hydride transfer takes place. H minus will attack this carbonyl carbon and C double bond O will break on O minus. So this process takes 4 times. So as a result you will end up with this species and this upon hydrolysis with acidic workup you will end up with 4 equivalent of alcohol. So usually lithium aluminum hydride reduces aldehydes, ketones, acids, acid chlorides, esters, nitriles, imines and nitro group. The next is sodium borohydride. So this is the structure of sodium borohydride Na plus BH4 minus. So how to prepare this reagent? So you have to start with sodium hydride plus BH3. So you will end up with Na plus BH4 minus. So if you start with this carbonyl compound and react with sodium borohydride, you will end up with alcohol. So what is the mechanism for conversion of keto compound to alcohol? So here again BH4 minus, so again hydride transfer will take place. So H minus will attack to this carbonyl carbon and C double bond O will break on oxygen. So you will end up with this tetrahedral intermediate O oxyanion. So this oxyanion takes the proton from solvent, let's say alcohol. So you generate the alcohol plus OR minus. So this sodium borohydride reduces aldehydes, ketones, acids, acid chlorides and amines. Sodium borohydride does not reduce C double bond C and C triple bonds. So this is the limitation. So next is Meruin-Ponder-Burley reduction reaction, MPB reaction. So what is that? Aldehydes and ketones can be reduced with aluminum isopropoxide in isopropyl alcohol to corresponding alcohol. Is called MPB reduction. So this is the carbonyl compound, let's say acetone. You react with aluminum isopropoxide and isopropanol. You will end up with a alcohol. So acetone, oxygen has lone pair of electron, it will act as nucleophile, it will attack to aluminum. So you will end up with aluminum oxyaluminum complex. And so this complex we have to write in this fashion. So there will be internal hydride transfer takes place. So So H attack as H minus, and C double bond will break on O plus, and this Al oxygen, aluminum oxygen will come here. So as a result, you will end up with acetone and this oxygen aluminum complex. So again there will be a proton exchange with isopropanol giving rise to alcohol, and again aluminum isopropoxide back. The next is addition reaction of unsaturated carbonyl compounds, that is called Michael addition. So nucleophiles or carbanions undergo 1,4 addition reaction with alpha beta unsaturated ketones, give rise to the product called Michael adduct or Michael addition product. So here this is the carbonyl group, and with respect to this is alpha and this is beta. So this is alpha beta unsaturated carbonyl compound. So if you react with acetone and sodium ethoxide, okay, so this will undergo 1,4 addition reaction. You will end up with this product. Similarly, dimethyl copper lithium also undergo 1,4 addition, that is called Michael addition product. So what is the mechanism? So we have acetone in the reaction medium. So ethoxide will take the proton and this CH bond will break on this carbon. So you generate this carbanion which is resonance stabilized. So O minus will come here and C double bond will break on oxygen. So this is resonance stabilized. So once you get this carbanion, so this carbanion will undergo 1,4 addition, because usually in carbonyl group O minus and C plus. So once you generate this C plus, so due to the conjugation with double bond, so this C plus is resonance will go under resonance. So the C plus will come here. So that's why this carbanion will attack this C plus, and this will go here, and this C double bond O will break on oxygen. So you get this oxyanion, and this oxyanion will take the proton from ethanol, giving rise to this enol, and this enol simply tautomerizes, giving rise to the Michael adduct, to a 1,4 addition product. So I have a simple problem for you guys. Please write down the Gilman's reagent, that is dimethyl copper lithium. This will undergo 1,4 addition product. So please write down the mechanism for this reaction. So please subscribe to our channel Chemistry Live UGPG. This is also available in the website www.chemistryliveugpg.com. For class 11th and 12th students, this is the channel Foundation Chemistry AV. This is also available in the website foundationchemistryab.com. So this is a simple step towards e-learning, making life better. Thank you all for learning.